To understand the benefit of string builder, you first have to understand that in Java, strings are immutable. They can't be modified. Let me first show you an example that appears to contradict this. I say string s equals hello. And then I say s equals s plus, string concatenation, world. And then if I print out s, sys out, s, and I run this, as you might expect, it prints out hello world. So it sure looks like I've modified the string s. But this is really not an adequate test case. You can't tell if I modified the underlying object or if I copied the original string, built a new underlying object, and assigned it back to the variable. So I need a better test. So I'll say string s1 equals hello. And then I'll say string s2 equals s1. And I'll say s1 as on hello world. I'll print out s1. And I'll also print out s2. Okay, so this one, s1, of course is going to print out hello world. But the question is, what is this one going to print? Is it going to print hello or hello world? Well, I already tipped my hand. I already told you strings are immutable, can't be modified. So that means the second one is going to print out hello, not hello world. Sure enough. So this shows that the first line where I do what appears to be string concatenation is actually a combination of string copying and string concatenation. In particular, that string was copied. So what appears to be string concatenation really involves copying. This has performance implications in a few applications. Okay, because strings are immutable, they can't be modified, it means that repeated string concatenation can be very expensive. So for the few cases, not very many, for the few cases where you need to do repeated string concatenation, Java gives you an additional class, string builder. String builder is mutable. When you append using the append method of a string builder, it doesn't copy the previous one, it modifies the existing one. Let's see why that matters. So suppose that you didn't know about printf and you wanted to line some things up. In other words, you wanted to make a method called padcars, where if you say padcars 5x, it returns 5x's. If you say padcar 10 and then a space, it returns 10 spaces. And suppose you tried this implementation. You said, all right, start with an empty string, and then loop around that many times, and just stick the second argument on the end. Well, that does indeed give the right answer. If I say padcars 5x, it returns 5x's. But the question is, how long does it take? Let's say it takes a certain number of milliseconds for a 10-character string. How long does it take for a 20-character string? Twice as long? What if I make my string 100 times longer? How much more does it take? What if I make it 1,000 times longer? Well, you would think, the person who wrote this code would think, well, if I make the string twice as big, it takes twice as long, but it doesn't. If I make the string twice as big, it takes 4 times as long. If I make the string 1,000 times bigger, it takes 1,000,000 times longer. In other words, the performance grows as n squared. Why? Well, we need to explain that. Okay, so we said repeated string concatenation inside a loop can be expensive if the loop can ever be big. And we made a kind of naive version of a method called padcars, where the idea was if you called pad characters an x and 4, you got back out a string with 4 x's in it. And the string version is bad, which is why I want to introduce a version that uses string builder. But before we see how to fix it, we need to see what the problem is. Why is this so bad? So I start off with an empty string. And then I loop n times, n would be 4 here, and I just take the thing that you pass in, the x, and I stick it on the end of the result that many times. Seems perfectly logical. And the question is, how long does this take as a function of n? Another way of asking the same question is, if we make n twice as big, how much more time does it take than it did the previous time? If we make n 10 times bigger, how much more time does it take than it did the previous time? If we make n 1,000 times bigger, how much more time does it take than in the previous case? Well, to answer this question, we need to say, I'm doing string concatenation, and that string exists already. But you can't actually modify a string, as we just saw. Strings are not mutable, which means that thing must be copied each time around the loop. So how many wasted copies is it doing? How many wasted characters is being copied? Well, the first time around the loop, there are 0 characters. The next time around the loop, there's 1 character. The next time around the loop, there's 2 characters and 3 characters and so forth. So the total number of wasted copies it does is the sum, hang on here, I'll explain this, from I equals 0 to n of I. 0 plus 1 plus 2 plus 3 plus 4. What's that sum? Well, every computer scientist knows this by memory. That's n times n plus 1 over 2. And the big point is that that grows as n squared. Uh-oh. What that means is, suppose it took a certain number of milliseconds to do this for some n. And now you make n twice as big. It now takes 4 times longer, not 2 times longer. If I make n 1,000 times bigger than it was before, it takes 1,000,000 times longer than it did before. That's bad. So if we're going to do repeated string concatenation inside a loop, and the loop could ever be big, we can't use string. We need something else. All right, so now let's redo the previous example using string builder instead of string. So we make a string builder with an empty string. We use the append method. Remember, it's mutable, so it doesn't involve copying, and stick the second argument on the end a fixed number of times. And then I turn it back into a string at the end. So what's the performance? Well, since it's mutable, the performance is linearly associated with the number of characters. In other words, if I make the n twice as big as it was before, it takes 2 times longer. If I make n 10 times bigger than it was before, it takes 10 times longer. You can't possibly do any better than this, so this is the optimal solution. But I want to caution you, don't bother with string builder unless you have some profiling, some benchmarking that shows that your string performance is actually costing you something. If your strings are short, you do 1 or 2 or 3 or 4, even 10 string concatenations, no problem. It's only when you do a very lot of string concatenations inside of a loop, where the loop variable can be big, that this n squared performance of string concatenation costs you something. So be cautious. You're not going to use this very often, but keep in the back of your mind that for fancy string modification cases, there is a mutable class corresponding to string, and it's called string builder.